And next up, we have Evan Jones.
So picture yourself in the grocery store, maybe walking down the seafood aisle. You'll probably see some Atlantic salmon, some steelhead if you're in Idaho, and probably some catfish and shrimp and maybe some other things. It's becoming increasingly likely that a lot of this food has come from aquaculture farms. The world is becoming more and more reliant on aquaculture in order to produce fish for us to eat. However, this industry as a whole loses greater than $10 billion annually due to preventable diseases. And most of this loss occurs within the first 6 months of the fish's life when they're very small and susceptible. So one of the main tools that we have to prevent those losses is everybody's favorite word right now, the vaccine. However, most of vaccines that are used in aquaculture are injection-based. And these are really labor intensive, making them very expensive, and they're also really stressful for the fish. They also can't be administered to those small fish that are most susceptible. The holy grail of vaccination technology is actually an oral vaccine that you can feed to the fish. I think we could all agree it'd be much nicer to wait in line at the pharmacist for a pill instead of our shot in the arm. However, current oral vaccine technology involves coating the vaccine in a microparticle, which is then coated on top of the fish food. These microparticles can easily be lost to water, so the fish can't even take it up, and they're also easily broken down in the fish's stomach, when really the vaccine needs to make it all the way to the intestine before it's broken down in order to provide an antibody response and increase that immune protection. What researchers at Oregon State University have done is develop a fish vaccine pill that's the same size as fish food. They've also added some flavors into it that promote feeding for the fish, kind of key in on it. This encapsulation method should also protect the vaccine in the stomach, allowing it to get to the intestine to promote that antibody production. In my research, I'm going to feed these particles to rainbow trout, which are an established aquaculture species, as well as sablefish, which is an emerging aquaculture species. And that just means that I have to develop some new tests in order to measure those antibody levels in the sablefish. But if these oral vaccine particles can promote a similar antibody response and immune protection as those current injection-based models, then we are able to decrease vaccination costs for aquaculture farms greatly, as well as increasing the amount of fish that can actually be given the vaccine, including those most susceptible small fish. This should generally decrease production costs across the board for aquaculture farms, as well as hopefully leading to lower costs for fish at the grocery store for us. Thank you.
Thank you, fascinating. So you're going to be feeding fish a pill, more or less. Where are you going to get these fish?
We have kind of a partnership with Riverence Farms as the largest trout producer in Idaho. And so they'll actually give us eggs and we raise them up in the College of Natural Resources in our wet lab. So it works out pretty well. And these sablefish they're a marine species. So Oregon State University is actually doing the live fish trials over on the coast there.
Okay, and then you're just going to be running the data and seeing the impact?
Yeah, well, we'll actually be feeding them to rainbow trout at our College of Natural Resources. And yes, I'll be running the data for the sablefish, even though they'll be vaccinated over in Oregon.
Okay, very interesting. Thank you.
Yeah, thank you.